means it is a computer system that models on the human brains and the nervous system. So it is also a typical organized layers that are made of the numbers of interconnected nodes which contain and activation functions. So representing this diagram, each show many layers. So the first column of the layers is called input layer. So this is how we put our input layer. And in the next, the hidden layers are the connected to each other nodes. So these are the hidden layers. And the last of the column is the layers, which is called the output layer. Okay, so connections of lines that it represents as weighted connections. So all of this in these diagrams are called neurons. So this is how the neural networks work.
In other diagram shown here that represents two nodes and one output connected by weights. There will be having two weights called W1 and W2. And first node, namely M1 or measurement 1 and M2 or measurement 2. We simplify the M1 multiplied to W1 and M2 multiplied to W2. Get the sum of simplified numbers added by the bias to get an output. It will be called sigmoid function. M1, M2, and bias are randomly set, and M1, M2, and bias are parameters used in neural. Weight 1, weight 2, and bias are randomly set.
A while ago, they have discussed the sigmoid function. M1 times M2 plus M2 times W2 plus the bias equals the sigmoid function. After we get the sigmoid function, we will undergo activation function where 1 over 1 plus exponent of negative x. The value of sigmoid function will be replaced to negative x here. Suppose we have two inputs. First input is 0.53 and the weight is 3.14. Another one input is 0.14 and the weight is negative 2.71. First, we simplified the first input. 0.53 times 3.14 equals 1.66. Then another input 0.14 plus negative 2.71. Take note, in graphing sigmoid function, each output should be greater than or equal to 0 or less than or equal to 1.